Hello DSci2000. In this video, I'm going to go through data visualization using ggplot2. Here's the usual objective slide. Please pause and read before proceeding. So before we do anything, I'm going to go to my DSci2000 folder, and I'm going to open up the R project file. Let's just close anything that you might have loaded. And we're not going to use an R markdown today. We'll keep it simple and use an R script. And let's save that to unit 5. Let's just call this ggplot2. And let's just do our usual add and commit of this file. Go to your DSci2000 folder, right click, git bash here, cd to unit 5. Let's do a git add on ggplot2 and git commit. And a push. And let's minimize that for now. So the first thing I want to talk about is recall the iris dataset. I had introduced this earlier in the semester. Let's press Control Enter. And let's scroll up a little bit. Recall this is what the iris dataset looks like. Each row represents a particular flower. We have 4 particular measurements that were done on every flower, as well as the species of the flower, which could either be Setosa or versicolor or virginica. Our goal today is just to learn how to use ggplot2 to visualize these data. So before you do anything, make sure you install the ggplot2 package, and then we'll load the ggplot2 package using library. Let's go to the console on the bottom left. Let's do install.packages on ggplot2. Let's scroll up. We don't need iris anymore. Let's just do library ggplot2. Press Control Enter. And now let's say that I want to build a scatter plot using the iris dataset with sepal length in the x-axis and sepal width in the y-axis. So let's just go ahead and go through this process. The first thing you're going to need to do to create a ggplot2 graph is to first create the canvas. How you create the canvas is as follows. We're going to do ggplot as a function. The first argument is going to be the data frame. The data frame's name in this situation is iris. Let's put a comma there. The next thing you're going to want to do is to specify your aesthetics. Aesthetics are specified using the AES function. I'm not going to go into great detail on what these are, but for the intents and purposes of this video, just know that your X and your Y values are going to be your aesthetics for this particular graph. So in this example, we want sepal length in the x-axis and sepal width in the y-axis. Those are going to be our aesthetics in this situation. So here I'm going to do x equals sepal dot length and y equals sepal dot width. Let's press Control Enter and go to the bottom right. RStudio should show you a plot, and we have plotted our blank canvas with sepal length in the x-axis and sepal width in the y-axis. So we've created our canvas by specifying our data frame as well as our y and x aesthetics. So we've created our canvas. However, creating a canvas on its own does not tell ggplot2 what to draw. All we've done is created a canvas, and now we need to tell ggplot2 what to draw. What we're aiming to do here, in this situation, is draw a scatter plot of points in this canvas for every point of sepal length and sepal width that we have. Let's go to the top left. To tell ggplot2 what to draw, you're going to need to specify what are known as geomes. I'm going to add a plus sign after this canvas and press Enter. And then I'm going to write geome point right there. And I'm going to press Control Enter and go to the bottom right. I now see that my blank canvas has points inside it, which are my geomes. Geome point adds points to my canvas. Points are the geomes in this situation. You can also do line graphs, such as geome line. Let's press Control Enter. It doesn't look that great, especially given how scattered the data are, but just so you know, that's how you do a line graph. And there are several other geomes you could use as well, which I'm not going to get into, but for the intents and purposes of this video, I'm just going to stick with geome point. So just to review, here we specified the canvas, and here we've specified that we want to work with points. Let's make this plot look better. The first thing I strongly recommend doing is using a black and white theme with your graph. How you do that is as follows. We're going to add another layer to this ggplot2 function by putting a plus sign before our comment. And let's press enter at the end of line 4 here. And we're going to do theme underscore BW for a black and white theme. Let's press Control Enter, and on the bottom right, you can see now we're working with a black and white theme. The next thing I'm going to do is get rid of those grid lines, i.e. these lines that are vertical and horizontal here. How you do that is as follows. Let's add another plus sign right after theme BW. Press Enter after this line, and we're going to do theme as a function. And we'll do panel.grid equals element underscore blank. So this gets rid of the grid lines. Let's press Control Enter and look at the graph. And now the grid lines are gone. The next thing I'm going to do is I'm going to provide ggplot2 more readable X and Y axis labels. Observe here that sepal width and sepal length have a dot in them. I want to just get rid of that dot. Here's how you would do that. Right before the comment after theme, put a plus sign. Let's press enter at the end of line 6 here. And we're going to do xlab sepal length and another plus sign and enter ylab sepal width. Here, this is the x-axis label, and here we have the y-axis label. Let's press Control Enter. And now we have better axis labels. Now let's talk about controlling the axes themselves. Let's say I wanted to make my x-axis go from 4 through 8 with ticks every 1/2. Here's what I would do. I would use scale x continuous for a continuous axis on the x-axis. My limits of 4 through 8 tell me the minimum and maximum of the x-axis. And breaks indicates to me where the ticks occur. Remember that SEQ 480.5 means all numbers from 4 through 8 incremented by 0.5. So this is why you need to use the SEQ function for ggplot2. Let's go ahead and do that in our code. Put a plus sign after ylab. Move to the end of that line. Press enter. We're going to do scale x continuous limits equals c 4 through 8, and then breaks equals SEQ 480.5. And this is making the x-axis go from 4 through 8 ticks every 1/2. Let's press Control Enter, and here's the resulting graph with the desired min and max values as well as the ticks. Next, let's suppose that we wanted to make our y-axis go from 2 through 5 with ticks every 1. Similarly, we would just throw that into scale y continuous. The syntax is exactly the same. I'm going to add a plus sign right here. Put my cursor at the end of that line, press enter. And we're going to do scale y continuous limits equals 2 through 5. And then breaks every 1. We don't have to use the SEQ function because we're just incrementing among the whole numbers. And remember that a shortcut you can do for that is just simply 2:5. So this makes the y-axis go from 2 through 5 ticks every 1. Let's press Control Enter. And now you can see that the y is going from 2 through 5 with ticks every 1. Another thing too is that in geome point, if you wanted to, you could also specify the color. So here I've decided to make them all forest green. I will let you do this on your own if you'd like. The next thing I'm going to discuss is coloring based on the values of another column. And recall that there are 3 species in the iris dataset: Setosa, Versicolor, and Virginica. And let's say I wanted to color each data point in this graph based on the type of species it is. So what you would do is you would specify color as an aesthetic. You would specify color as an aesthetic because the color is directly coming from a specific column of the data frame. Let's go ahead and do that. So we're going to write color equals species. And let's just press Control Enter. And now we have a scatter plot where each point is colored depending on the species it is. Another thing you can do is you can impose functions on top of graphs. Let's say I wanted to throw this function 0.125 times x squared onto my graph. Let's define that function first. Here we're plotting functions in R. We're going to call f a function with one input, which is going to return 0.125 times x squared. Let's press Control Enter to define the function. Make sure it appears on the top right over here. And here's what you're going to do. You're just going to take our prior code and you're going to add this line right here, stat function, to plot that function. That will add this blue line that you see right here. Let's go ahead and do that. I'm just going to copy and paste this code. And we're going to add to this stat underscore function fun equals f. And this will plot the function f. Let's press Control Enter. And you can see that that function 0.125 times x squared has been imposed on top of this graph. You can also do linear regression using ggplot2. How you would do that is geom smooth with method equals lm, lm standing for linear model. So let's go ahead and do that. I'm just going to comment this out just for our records. I'm going to press Enter, and we'll do geom smooth method equals lm in quotes. So this does a linear regression for each color of points. Let's press Control Enter. You can see here that's in a linear regression for each species. Here's the Setosa linear regression line. Here's the Versicolor linear regression line. And the blue one is the Virginica linear regression line. There's of course much more to ggplot2 than what I've presented to you here. However, the material that I've shown you here should be sufficient for your purposes. And if you have any additional questions on graphing, please let me know of them. I strongly recommend reading Our Graphics Cookbook by Miller-Chang. What's really nice about this book is that it is now available for free online. You can just go to this website and check it out. I have used Our Graphics Cookbook throughout many of my jobs as a reference, and I strongly recommend that if you really want to get to know ggplot2 well, you should look through this book and learn the techniques that are in that book. That's all I have for you. Let's just go ahead and save our ggplot2 code. So this is red right here. Let's hit Control S to save it. Then let's go to git bash. Reminder that we're in the Unit 5 folder. CD to that folder if you're not there yet. Let's just do a commit. Let's just do a push. Let's close git bash. Let's close RStudio. It's going to ask if you want to see the workspace image. Please don't. And that's all I have for you.